Hello and welcome to the RSnake Show, another demo day. Today we have Adam Bateman from Push Security. As with me, per usual, is Trey Ford. And so why don't we let Adam have his time? Ready, set, go.
Cool. Thanks for having me on. Yeah, so my name's Adam Bateman. I'm co-founder and CEO at Push Security. Been in the industry for a couple of decades. First decade of that was red teaming, doing sort of offensive security, pen testing, that kind of thing. And then the second half of that was blue teaming, so detection, instant response, a similar background to you two. Push Security, we literally, our headline's stopping identity attacks. So if you like categories, which I'm allergic to, as sure a lot of people are, but ITDR is what would fit into identity threat detection response. So the three co-founders we have we're all from a really similar background, kind of that red team heritage. And we just knew, we spent a long time attacking infrastructure. We knew that attacks were going to start moving off of the endpoint and start moving somewhere else. We got ahead of the problem. That's what we do in Push Security.
That's great. So why don't we switch to the demo? Sounds like you don't have any slides, which is always preferable. So
I'll spend my whole life in slides, so more tech stuff I can do. Let me just share. So you should be seeing a Push dashboard right now.
Yep.
Good. Okay, cool. So this is the Push Security platform. This is the admin panel, which is what you would see if you were the security team driving the platform. Some people use the platform itself. Other people see us as a kind of a telemetry collector. And so they would actually just set up webhooks, use the APIs to draw everything into the SIEM. What we do, which is really novel, is that we talk a lot about people say identities are the new perimeter. That's like become a big tagline over the last few years. And we talk a lot about how in the 2000s the network or the company perimeter was all about open ports on public IP address ranges, and that's kind of changed as we raised the expense of attacking the traditional network perimeter. The attackers shifted to the friction point, which was attacking endpoints. And then we saw the birth of kind of EDR, lots of telemetry on the endpoint. And that's, of course, caused attackers to go off and now start attacking identities in the cloud. So if you think about the attack surface as thousands of identities scattered up and across the internet, that's the attack surface that everyone's trying to deal with. The problem is it's really tough for you to map that attack surface out, right? Because you can't just port scan it. You can't write a script which brute forces every possible account combination across every single app that's out on the internet, hoping you get it right to map that out. It's really difficult. So how do you map it out? The thing that all cloud identities have in common is they traverse through the browser. So the way Push works is you can think of it a little bit like, I guess, like EDR, but inside the browser. So you deploy out a browser extension in the same way you would with an EDR agent. So like via MDM, which I'll show you in a second, but rather than installing itself as a new bit of software and yet another agent on the actual device, it plugs itself into the browser. And then the browser starts streaming back telemetry. You can see identities. You can block identity attacks directly. All right. So I just want to give you that context as I show you around, and you'll sort of see how this works. So
interesting.
What you should see at the top here, the browser extension, which is running now. This actually is, I've pinned this using the sort of Chrome profile settings just for the demo purpose. You can hide that away. If you right click on this, it will say to you, installed by administrator, you can't get rid of it. Right. So what happens here is, if I first of all just start off with the down here, if I just start off, so deployment, we support all browsers, feature parity across everything, which means all operating systems. So Linux, Mac, doesn't matter what you use, even Chromebooks. So we have a lot of our customers will use us. They've actually been deploying Chromebooks out to non-technical staff because it reduces the attack surface. It's much, much cheaper. But the problem they had is you can't get visibility there. But with Push, you just deploy straight into the browser, it runs inside Chrome, then you get visibility and it deals with the sort of main attack surface there. So doesn't like across every OS, every operating system, this works all together. And all you do is download a config. You can use group policy, you can use Jamf, you can use whatever you want here. You just download the config for the devices you want, and you deploy it out via MDM. So most people will just deploy it for all browsers in one go, and then whatever is installed, those browsers will check back in. And then what you'll start to see is all the browsers in the organization just start connecting in like this. And that telemetry is now being streamed back. So you can then chop that data in a few different ways. So you can see like a per employee view. So here I can see, Jeff has got 36 different accounts running across all these different browsers. I can dive down to this. You can see all the different browser profiles. You get an overview of all the different accounts and sort of health of those. You can slice this by app. So you can see the app view. So this gives you like a full app inventory of everything that's being used. Doesn't matter if it's on SSO or not, because we're pulling it all from the browser. And so you can see here, like, some of these are behind Okta, some of them aren't. Some of them, actually, you can see both, which is kind of an interesting problem because people think that once something's connected to SSO, it's secure, but they don't realize there's a term we named ghost logins, where actually people just browse, even if it's on SSO, they just go directly to the SaaS application login page and they log in locally anyway. And so when attackers do cred stuffing, they're just effectively going straight underneath SSO. We see that a lot, so you actually get to pick those up as well.
So I'm sure you have already encountered this at some point, but are you finding that you're also accidentally picking up people who just have other jobs and they're doing those other jobs at work and they shouldn't be?
Yeah, it's a good question. So we kind of actually, one of our really, really early design partners a few years ago when we launched was a German fintech, and it was really good for them because they are particularly with privacy focused. We built privacy into this from very, very early on. And so one of the things we do here is the things that we track by default are work relevant applications, right? So if it's a login to your, airplane booking site or cinema, we don't pick those things up. They're just kind of left alone. And outside of that, equally, you actually whitelist the domains that you want people to use. So if I could show you in here,
but people do use EC2 at work, and they also use it for their, side business or their consulting practice that they're running on the side or whatever.
Yeah, absolutely. So that's why we whitelisted particular domains as well. So you'd add your company domain in here, and then the extension is scoped to specifically look for company domains and company logins. You can though turn this on if you want to. It's off by default, but you can turn on all. At which point you would then see personal logins as well. So you would then see people logging in with Gmail or whatever you want to. But it's off by default, and then we allow people to turn that on. It really caters for because different people have different company cultures and policies, right? Some people just say, look, if you're using a work laptop, it's a work asset. You should not be doing anything personal on it, and so everything's going to be logged. Other people have a different policy, which is where they say, people can use it for all different types, personal and otherwise, and therefore I'm going to keep it strictly to what is company owned, like company domains. So you get both options there.
Which is all fun and games until you're doing an investigation. Like once the forensics get started, like you find out that's not entirely true.
Mm-hmm.
Yeah.
Yeah. My concern with the whitelist is, but what asset inventory are you using to define your whitelist? You know what I mean? Is that thing up to date? And
you're willfully missing all kinds of domain surface area, right?
Yeah.
Yeah, so the extension detects new domains and then it suggests them. So they end up actually just appearing on the list, and then people go in and they just click add, and then they're added in. So as those come through, they pick them up and people just add them in that way.
Mm-hmm. Mm-hmm. Yeah, they'd have to stay on top of that. That'd be important.
Yeah. So this is then like a really high fidelity app inventory. Like if you've ever tried to build out an app inventory by using kind of like a CASB or doing something at a network traffic level, one of the big problems we saw that people have is because you're looking at network traffic, it's sometimes hard to distinguish between if someone's just sort of visited an application or whether they've actually logged into it. But because we are in the browser, we're actually detecting successful logins and active sessions in the browser, and so you can see really, really accurately that someone's actually used this. But I guess if you're thinking about the identity attack service, this is like the host IP level. The bit that really matters is the level beneath that, which is the account level, right? This is your identity attack surface. This is the bit where most of that value comes in. So here you can see every login that occurs. You can see here that, ones that are behind SAML. You can see if they're a password. You can see if they're IDC. So, the famous Snowflake breach that happened recently, if you were in here and you said you just went to search in Snowflake, You could easily just say, okay, well, 7 accounts, 2 of them are on SSO and a bunch of them aren't. And you can see here there's like leaked passwords. We can observe inside the browser that they haven't hit the MFA prompt, so we know we can infer MFA is not there. You can see if there's a weak password as well. We're really focused on anything that has anything to do with account takeover. So you can sort of see different login methods. One really popular feature is like you can actually, the extension to determine if someone's using their password manager. And so we can actually infer what password manager. You can even see if there's a clipboard paste there and something's been used at that point. So this is good for doing things like, I don't know, maybe you're meant to be using one password across the whole company, but you've got someone who's like logging in, syncing their passwords back to their Chrome profile, and you want to determine that. So this is a really popular feature as well.
It's very cool. I guess the question I'm sitting here asking is, okay, so in theory, you've got visibility across the entire enterprise endpoint fleet of browsers. In theory, I'm going to now log in from my iPad or my personal machine. Of course, you're not seeing that because you're not running in those browsers. Is there a path to identify or start speaking to logins? Like, you're not tapping into log streams coming off of these SaaS or other service endpoints. How do I start identifying logins from rogue devices?
Yeah, so we do also, you can do integrations back with your identity provider directly as well. So you can connect in with Entra, with Okta. We pull identities from there. We do some detections there as well. What I will say, though, is that browser extension support is rapidly developing for mobile devices. Actually, we are right up against the kind of edge, waiting for the browser technology to get there. So we've actually already built, you can actually now install browser extensions in iOS. You can get them on iPads, you can run them in your sort of mobile Safari. That works. We're going to be shipping that very, very early in Q1. It's really been about waiting for the browser vendors to get to the point where they've done that. I think like Edge is currently got browser extension support, but it's in beta. We've already developed the code for it. We're waiting for that to come out of beta, and we'll ship that as well.
Nice.
So
it just strikes me that the old world $64 million question of like, talk to me about your device inventory. You actually can do this from a employer user centric standpoint. Here's where they're logging in from. Here's where they're using their accounts from. And oh, by the way, Okta, Intra, these others, there's a handful of users using other endpoints that are not monitored or protected, but this is the total surface area of where these accounts are being used.
Yeah, exactly. And when you start to sort of actually send all this information back to your SIM and you correlate data together, it gets really interesting, right? So for example, let's say without push, you were pulling AWS logs into your SIM and you alerted on like, hey, an admin just disabled MFA. So like, admins probably just disabled MFA. If you can say, hey, an admin disabled MFA and it didn't come from the browser because the login didn't happen after a period of time, it becomes much interesting. All right.
Yeah.
So it just sort of shows you just a few other things that you can do here, like as well as just getting visibility, you can start to do some kind of really interesting attack detection use cases.
You can I think you could also do something kind of cool here where all these companies are behind some sort of proxy somehow, or natted or whatever, so they're sort of hidden from view. And also a lot of companies have shared like admin accounts, which is a terrible idea, but they all do it. But who was the person who logged in? You know it's admin, but you don't know who was the admin. And so this is actually the first time I've seen a way that you could actually pierce back to really figure out who they are specifically. Like, oh, it's this guy here who logged in as the admin who did that function that caused the problem.
Yeah.
It was Robert in the library with a candelabra on the Edge browser on his work machine.
Right? I mean, I think that is a thing you get to do with this, right?
Yeah, I mean, effectively, you have a full audit log of what employees are logging into and what's happening. It's like it's a whole new telemetry source. So like when it comes to detection and response, we say quite a lot that you've had endpoint telemetry feeding into your SIM for a long time, and you've had network RDS streaming in for a long time, and then you've had logs from various devices like IDPs and more recently cloud-based kind of IDPs. Now you got browser telemetry, right? So it's a really, really unique viewpoint. And it gives visibility in lots and lots of areas. So yeah, we're seeing our customers get kind of creative and use it for those sorts of use cases.
I'm sure.
Cool. Yeah, so I mean, really, this part that I've shown you is the side of mapping out attack surface is just one big reason that people use us. The other half of the product I'll show you is the sort of controls page. Now, everything on here is set and forget, right? So the other side, I guess, is a bit more posture management or detection of particular logins that are happening, so you can track those events. But some of the things that we're seeing that are really interesting as well is we can do things like, for example, SSO password protection. I'll start with here. So what happens here is the browser extension actually detects when an employee logs into their IDP and it pins it to the login screen. Right, so we detect that login, we associate that login with that official login page, and the employee cannot enter anywhere else. So it prevents corporate password reuse, but also completely takes out credential phishing, because if an employee can't enter their password into something else, it's really, really difficult to phish someone. So you can see I'll show you how this works on the employee side in just a moment, but you can put this into sort of monitor mode, so you can see, you can just get visibility. It means it won't have any interaction with or the employee won't see anything at all. Or you can put that into full block mode, where actually show the employee a block screen and prevent them from going ahead.
What is the phishing one that's similar to the URL blocking?
Yeah, so with PhishKit detection, what we're seeing is some really interesting ways that PhishKits are now evading detection for like SWGs and kind of mail solutions. So really popular tools like Evil Jinx, but there's Evil NoVNC, there's like Naked Page. There's so many different fish kits that are coming up now. And these new fish kits aren't designed just to steal username and password. They're actually designed to steal sessions directly at the browser and bypass MFA. But what we're seeing is them, because of the fact they know that as a phishing link passes through like a mail gateway, that mail gateway will take that link out and then it'll go back and query the fish kit to determine if it's malicious. They're doing crazy things to evade detection. Like they're hiding them on legitimate domains through like Cloudflare workers, and then they're putting recapture in front of them, and you got to send special headers to them, special GET requests. Sometimes you have to, it will only if the target user account logs in, it will return the fish kit, and if it returns some other domain, it won't. Right? So there's a whole bunch of things that happen, which makes it really difficult to detect. Because of the fact we're in the browser, the employee can click a link anywhere, not just in the email, but it could be like a LinkedIn Messenger or anything. Like we've even seen a phishing link hosted on someone's SharePoint at some point, and an employee just clicked that. It then unpacks into the browser, and we actually detect that payload, and we can actually fingerprint and identify the fish kit then directly and block that as well. Right, so the combination here of these two are really powerful, because you can directly fingerprint what fish kit it is, just you sort of understanding the payload. And even if they do something clever and get past that, when they go and enter their password into it, we block it that way. Similarly, we have clone login page detection. So as all the employees are logging in and it's building out the inventory, the extension's also profiling what the login page should look like and understand the structure of the legitimate company login page. So if then an attacker clones one of those login pages, an employee goes to visit one, it will detect that that's actually a clone of a legitimate page, and it will block that as well, right? So this works for both clone login pages, but also things like Evil Jinx. If you know how they work, they effectively proxy the legitimate login page, and it makes some subtle changes to it. So you've actually got 3 methods there for detecting those sorts of attacks.
Mm-hmm. Got it. Okay, cool.
Yeah, a couple of other cool things. So you can just do straight up URL blocking. So if you had like a list of ICs and you want to stream this back to browsers and block them all, this is kind of a cool, like really simple, but really, really cool. So session theft detection is a really big problem, like particularly things like info stealers. You get infected by an info stealer, it will then pull sessions out of the browser or adversary in the middle of attacks that we were talking about a minute ago. Once the attacker gets hold of the session cookie, they replay it, import it into the browser and replay it against the app, and it means they're just straight up authenticated. Really difficult thing to detect. What we do here is the browser extension will inject like a unique token into the user agent string of every request. That then appears up in your Entra or Okta logs. So effectively what we're doing is stamping every new session and saying the employee created this session, right?
That's cool.
Yeah, so if you then see one that's missing that, you know it's been replayed, right? So this particular version, you add this and you'd write your own custom SIM rules, but we're actually shipping in the next few weeks, because we've already got that IDP integration, that whole thing's just buttoned up and it will just fire off a high fidelity alert. So it just works out of the box.
So it's kind of like sending a nonce every single time. Does it change every time, or is it, how does that work?
I bet it'd be static, because then you're going to be running a query in your SIM looking for all session tokens without this, so you can flag them, right?
Yeah, at the moment it's static, but once we tie up the kind of IDP integration with that as well, like it's much easier to then sort of roll that and make it more random, if you see what I mean.
I guess I'm maybe not understanding. So if I steal it, am I not stealing that credential as well?
If you still, well, no, because the way that like an info stealer would work, is it pulls it. They tend to sort of pull them out of the local databases or off the hard drive out of the browser itself, if you see what I mean, but not necessarily actually grab the user agent strings. Certainly if you're doing sort of a fish kit and getting into it or whatever. So also sometimes those info stealers will take the session cookie and just push them back up to the attacker. The attacker puts them up for sale on the dark web, and so sometimes you just see people literally just buying stolen credentials and session tokens off the dark web and just replaying them directly. So any of those times that they're replayed, that we would actually pick them up and see them. So
got it. Okay.
And then another nifty feature we have here is app banners. This is about preventing or limiting identity sprawl. So like identities being created on places where you don't want them, or lowering the impact if an identity was compromised, right? So basically what you can do here is you can create these different rules, and you can do things like, you can say like inform, acknowledge, reason, and so I can say block for employees in, I don't know, sales, and then you can say like specific apps, like based on approval status, or storage apps, so like Dropbox or something, and then you can actually set these particular rules. So if then an employee goes off and browses to one of these, you can actually just show a banner here to actually stop them from accessing it. So there's a few different things you can do. I'll just show you here. So like, this one here might be an inform mode for this employee not to use LastPass, or tell people that they must use SSO or different login methods. So what I'll do is I'll actually show you this. If I just flip over to this side, this is really oh, hang on, it's not showing the screen here. Let me just reshare. There we go. So this is the employee view. It's exactly the same thing. We've got the browser extension installed over here. And so like if I browse off to, say, LastPass, you can sort of show this banner across the top, which is, it doesn't stop them, but it's just enforcing, just letting people know, for example, or like ChatGPT, please don't put this in there, you need to acknowledge. Or you could create a rule to sort of say, hey, this is an app, you can't use it, let us know why you need to use it, and those kinds of things as well. I'll just show you while I'm here as well. If I just sort of enter, I've just entered my SSO password into that page as a test. This is how that would actually work and what that would look like there from an attack detection perspective, just to show you the sort of employee side.
Can you do the same thing if I'm misbehaving and let's say I'm auto-completing or copy-pasting my credentials from outside of, say, LastPass or 1Password? Like, hey, looks like you're logging in without using our password safe. Can we talk about that?
Yeah, that's a cool idea, actually. So, I mean, whenever the employee types, we sort of detect the type events, and as soon as we sort of match that it was a critical password, like your IDP password being entered, before they get the chance to hit submit, we would block it. So it doesn't matter where it came from, where it was pasted from. Obviously, separately from that, we can detect whether or not it was a clipboard event or if it came from LastPass and all that. So we haven't yet joined those two things up.
Yeah, it's a cool idea. Like you mentioned that earlier. I'm just here thinking about it. I'm like, in theory, I should probably know my endpoint password, which should be, in theory, probably the same as my SSO password. And then I should know my password safe password, which isn't the same. And beyond that, everything should be feeding from wherever my secret store is. Like, I really shouldn't know any passwords outside of that. Yeah,
indeed. Yeah, that's a cool idea. I like it. Product team.
It'd be a terrible idea. People hate me, blame me. Please don't tell anyone I said that. Sorry, internet.
I'll just show you. So I'll just show you one other thing as well, because I mentioned at the start that some people will use the dashboard. Um, I mean, it varies a lot, but generally smaller companies will just use this dashboard as a standalone. They deploy all the browsers out, and then it will talk back to this, and they can control everything as I've just showed you here. But the other way you can use this is actually just, rather than us being yet another interface. I told you before, I've done a bit of time in detection and response, and you know how you want everything in sort of the single pane of glass and not having to log into lots of different things all the time. So we try to honor really being part of the ecosystem there. So some people just see us as like a unique telemetry source. So that's why the controls we've really built to be set and forget. You set them up, you leave them alone, and that's it. And then you can fire all the webhooks back into your SIM. So this here shows all the events that are fired. So really everything I've just done, and I showed you for the employee view, you can see all the events here. This is just like a 7-day rolling window. So again, not trying to be a SIM outside the SIM. You can just see everything that's happened. So you can see like this browser checked in. You can see SSO password was reused. You can see when a particular login event occurred. You can see when an app banner was displayed, ignored, and you just fire that back off to a SIM or a SOAR.
It would be kind of cool if you could also get a screenshot, because you are in the browser, right? You'd also be able to see, like, here's where they attempted to log their thing in on this time. So it'd be useful for training purposes down the road. You know what I mean?
Yeah, absolutely. Yeah, funny you should say that, because we are actively working on a new feature which actually allows you to sort of trace what happened leading up to a phishing event. And some of the things that are in that, that'll be coming in early next year, but actually you'll be able to see all the things the employees clicked on, different links they clicked on leading up to that event, including a screenshot of what actually happened. And you can see that there as well. So reading my mind.
Yeah, I mean, if you're going to go that far, I'd say just get screenshots of all of the things leading up to it.
Yeah.
That way you can really see exactly what happened where, because I think that's one thing that people know, that they clicked on a bad link. That it's obvious, but what they don't know is where it came from. Did it come from Gmail? Did it come from a chat board? Like, where did this thing come from? There's somehow this entered your ecosystem, and so let's figure that out first, and then, okay, should you have clicked on it? Where did you click on when you clicked on it? Did you type your password in? What did you type in? Where did you type it in? When did you type in? All the details, and that way you can actually replay it to the user, basically like a movie. You know what I mean?
Yeah.
Like here's what you just did wrong.
Exactly that. Yeah, and because we're seeing things like attackers will obviously still use email to deliver phishing, but we see people sort of follow up and send things through other channels as well. So they might send stuff that back down through, like I said earlier, LinkedIn Messenger. We've written a lot of blog posts on doing things like Slack phishing, where you'll use like Slack Connect to try and connect and then social engineer someone and send them in there as well. So yeah, if you're able to sort of understand exactly where the phishing links came from, and you can see different areas that they might have been delivered to a particular user, it's really, really useful for response and investigations.
So you mentioned the Okta integration. It creates alerts of some sort. Are those filtered through this system, or do you consider that sort of out of bounds? You connect to Okta, pull that into your SIM and SOAR or whatever, and correlate, or how does? I can't tell whether you're acting as middleware there, or those are sort of separate objects.
Yeah, I mean, a lot of the ITDR market at the moment, if you look at it, tend to be pulling logs from lots of different sources and different IDPs. And then they'll do some kind of detections on those and forward them off to your SIM as higher fidelity alerts. Like, we see a lot of people doing that. So we actually went the other way, and we were like, well, how can we add something new to the ecosystem rather than pulling existing logs and doing some logic around them, actually add a net new telemetry source. So we've been focused very much on that side of things. At the moment, we intend to go a lot further in the direction of actually correlating logs. So at the moment, what we're doing is providing, as I said, we provide all this login telemetry. People already getting their logs from, say, Okta, and then people are writing their own SIM rules inside using our data and Okta data together. But as it stands in the platform at the moment, we do the Okta integration to do a few things. One is, rather than waiting for employee to hit an identity, so let's say log into Okta for the browser to see that, it immediately imports in every identity straight away. So you have all that straight away in the dashboard. You obviously can then pull in immediately all the apps that are being used downstream. And then we do things like the session token detection that I was talking about, right? So instead of having to just inject the one-time token and then you have to write your own custom rule, we inject the token in and then look for it ourselves in the Okta logs. And then those two things paired together, we can just fire a high fidelity alert and it will just come up in here to say session token detected in one go. So literally like 2 clicks and it's done.
Yeah, I could really easily see a situation where, an adversary somehow gets into the network, somehow gets a bunch of creds and starts logging in, but they're not necessarily going to log in from the same machine that the user originally logged in from. They log in from just whatever machine that they happen to be bouncing from. And so you'd see some interesting things there. Number one, they're coming from a place that they never came from before. Number two, they're maybe logging in aggressively, logging into a lot of places very rapidly. Like any one of those Okta systems or WordPress or anything else that has some logging function or login detection or whatever that you could hook it into individually, they may not see that. But because of your placement, you probably could see that, which is kind of interesting.
Yeah, absolutely. Yeah, exactly. You sort of infer that this didn't come from a user because you know where they are logging in from. You can see that happened. Yeah, exactly.
Yeah, this is the first time this user's ever logged in from Joanne's machine. Like, why is Joe logging in from Joanne's machine? Like, that never happens. Why is it happening? Get someone down there right away.
Yeah, that goes back to your shared credential consideration where wrong accounts on the right machines. Obviously we still see endpoint compromise. Do we still see actor in the browser type of compromises?
You mean in terms of adversary in the middle, or are you referring to something different?
Yeah, so rather than being in the middle, like the browser compromise, are they redirecting through browsers? Are they compromising browsers?
I mean, most of the sort of direct browser is sort of browser exploitation and getting onto the endpoint of what we've seen. But the adversary in the middle attack, like we often talk, we refer to that as sort of phishing 2.0. And obviously phishing attacks happen in the browser, if you see what I mean. So
right.
The way those work is effectively trick an employee to wind it back, right? Phishing 1.0, you clone a login page, you trick
and you donate
the
credentials
person,
to it, right?
Yeah, you trick them to enter their credentials into that. MFA was the big savior because then even if I got the credentials, I can't do much with it. The idea of the phishing 2.0, i.e. adversary in the middle, is you don't clone the login page. Instead, you get the victim to log in to the legitimate IDP or whatever you want to attack, but you proxy it through you in some way. And there's numerous ways that happens. So, but I would effectively get them to click a link. It connects to my proxy. I relay it onto the real victim and then pass it back. And because I'm the adversary in the middle, I can steal everything, not just the username password, but also the session token. So that happens from the employee's perspective in the browser. And so we can see that and we can stop them from entering their password into it. We can fingerprint it because we can see it's cloned because it's gone through a proxy. So it looks slightly different to how it would normally, and numerous other checks as well.
You'd see crypto failures and all the other stuff too.
We don't do that today, but you can, right? Once you're inside the browser, you get a lot richer telemetry because it's kind of, if you're on the endpoint, you can't really get into the browser in the same way. So it's the same way as like in traditional network detection response, you had network IDSs and you could see metadata, but you couldn't see inside the encrypted stream. And then what we did is we zoomed inside that by getting onto the endpoint with EDR, and that gave you much richer telemetry because you were on the endpoint. Really what we're doing is zooming in again and going a level deeper into the browser. And now we're inside the browser and you can actually see a lot more information again. So yeah, as attackers are trying to subvert more and more detection techniques, we're sort of following them and giving more and more visibility.
It's useful framing. I appreciate you breaking that out.
No problem.
Mm-hmm. So, can we look at the mail rules and some of these the investigative features? I'd like to kind of check those out as well.
Yeah, so we also, this is another thing we would do through API integration. So this would be an API integration with, say, Google Workspace or with Microsoft 365. So the same, you connect them with your IDP. But really what we're doing here is enumerating non-human identities. And these, in this sense, these are kind of OAuth grants. So if an employee's gone off and, connected in and connected an OAuth app for some reason, it then grants access to their Drive or Calendar or anything else. So you can see here straight away, like someone's connected Zapier, and I can dive down into this and I can say, okay, well, it's giving full access to their Google Drive, for example, and you can see everything else that's here. And so you can actually use this to, you can literally just revoke it directly and get rid of the integration straight away from this. If you've ever tried to do this in Google Workspace or Microsoft 365, it's a really tricky experience because you sort of see the different, you have to copy the ID out and then try and remove it, and it's a bit of a pain to do. So it's just a really, really easy way to make that happen. The other thing around with mail rules, the way that this works is it's a really, really common technique that if someone compromises like a mailbox of some kind, they compromise a Office 365 password or a Google Workspace account, whatever, in order to persist, then it's very, very common for them to create a mail forwarding rule of some kind, and they're very, very stealthy, right? So what they'll then do is, they're in the mailbox, they create the mail forwarding rule, and they literally just say something as simple as, if the subject contains the word important or finance, then delete the email and forward it off to the attacker. And at that point, then all sensitive emails are just being exfiltrated out to you all the time. What's more interesting, though, is that you can also do that for password resets, right? So if I gained access to this and I got password reset emails and forward them off to me, I now can go to every other SaaS application on the internet and just go forgot password, forgot password, forgot password, forgot password, and just reset everything in one big go and just gain access to everything else downstream. So we provide this detection in here as well, so you can see if there's any mail forwarding rules there. And again, you can sort of do the investigations, or you can delete them directly out of the mailbox here as well.
Interesting. That's cool. So you do have a fairly deep integration with 365 and Gmail. Is that what I'm gathering?
Yeah, for the mail rules, it's we have three integrations. Like the biggest integrations are Microsoft 365, Okta, and Google Workspace. But when it comes to OAuth and mail rules, that's obviously just which makes sense, right? Microsoft 365 and Google Workspace.
I mean, what else is there really these days?
yeah, exactly. That's like the entire planet. So
yeah, pretty much.
You still need some Zimbra and some Lotus Domino. I mean, like, there's a handful of what you really need.
Yeah. Yeah. There's a couple of other features coming that might be of interest because they're really, really close to dropping. Unfortunately, not on time for this demo. But one of the ones that we're adding soon to this screen is stolen credential detection. Now, this sounds like a kind of a commodity thing. Everyone's got a stolen credential feed, there's credentials up on the dark web. But as we saw from the Snowflake breach, it was kind of really high impact breach. And it's like the simplest attacker MO in the world. Someone bought some credentials off of the dark web and sprayed them across a bunch of applications, and you log in. Like, that's just something that shouldn't be happening. So if you've ever tried to get, one of these stolen credential feeds and go through them, basically there's lots and lots and lots of false positives. It's because often they go back years and years and years. So, an info stealer could have stolen someone's password and it could be leaked up on the dark web. But since then, that employee's left or the account's been changed. So over time, with age, the false positive rate increases and increases and increases over time, if that makes sense. The other thing is that if an info stealer steals a password from one particular application, he might be on the dark web saying, hey, this person's Dropbox password has been leaked on the internet, or their AWS password has been leaked on the internet. But what they don't always take into consideration is the employee's probably reusing that across 40 other applications all in one big go, right? So because of our position in the browser, what we're actually able to do there is as an employee logs in, we can actually diff that with ones that are directly on the internet. So you can see, hey, it's been leaked and it's being used, and it means it's like 100% fidelity. So you see directly that this password is actively being used by this employee and it's leaked and it's being reused across all these different applications in one go. So that's coming super, super soon. And then the other one is, what do you do about that? And what a lot of people ask is, can you force the employee to change the password? Absolutely, that's something we could do, but we found it'd be even better if you could force someone to enable MFA. If it's on an IDP, obviously you want to do that centrally. Unfortunately, a lot of the time it's not possible to do that. So what you do with this control is you can literally click on an app and say enforce MFA, and the next time the employee browses the application, it blocks the screen like in the way that you saw with the app banners, basically, and says, hey, we've detected you don't have MFA, you need to enforce this now. And it will allow you to go to the MFA page to enroll, and then it lets you into the application in one go, right? So it's just two really strong controls that you can put in there.
It strikes me as a great opportunity to stop and say, listen, the crap password you're using everywhere has been compromised on the entire web. I mean, there's a real opportunity to be like, one, it's crap. Number two, it's everywhere. Three, you need to not do that. Like there's so much there. And that goes back to that point I made earlier about like, look, if you're not copy pasting or you're not using the plugin, that crap password stuff's happening, and you have an opportunity to like stop that.
Yeah.
Yeah, very interesting.
People are going to hate me. I'm sorry. I'm going to get off that soapbox now. We're all guilty of it.
So normally I would ask something like about a failure mode here, but I don't think there really is exactly a fail. Like this fails open if it breaks, right? There's really nothing you're doing here that would cause
gaps in visibility. It's not going to interrupt, right?
Right. Am I reading that right?
Yeah, that's exactly right. I mean, just like a kind of endpoint agent would, it does its thing locally. It sends information back while it has an internet connection, just like an endpoint agent would in the same way. So, yeah.
And I guess we could Trojan their software. They see everybody's passwords, so we could be the penultimate enterprise-grade info stealer.
Yeah, so there's a lot of stuff we've done there. Like, it's worth mentioning that because that is something a lot of people ask about.
I'm trying to think about how you could be used to attack me, right? Like I'm grasping at straws, and it's a horrible one. That's all I've got.
Yeah, yeah, exactly. No, it's just a sort of peace of mind around that. Like, we don't transfer passwords out anywhere. Built by red teamers, so we sort of think about these sorts of things. But
it's who you want building software. I love that.
Yeah. So we like the way it works is like the browser extension will observe the login and it will do all the checks locally, and then what it sends back to the back end is weak password true. So the admin doesn't get to see the password. We don't get to see the password. Doesn't get sent anywhere. Common question that comes is, okay, but how then do we detect password reuse? The way that works is we observe as an employee logs in. We then take a hash of that password and we store it as a k-anonymized hash. Effectively, you chop the hash in half. We just store the first few characters of it, and you store that inside the browser sandbox. And then as the employee then comes to log into something else, we just diff it against that hash each time, right? So what's then sent back to the back end is app reused across these two apps.
An unuseful hash, basically.
It's really difficult to get it back. That's inside the browser anyway, but we don't send the hash back to the back end either. We just send the fact that it's being reused across these apps to the back end. So
even better. Yeah. That's good.
So we don't take anything whatsoever in that way. So we've done that to sort of keep that everything as secure as possible, and all that stuff happens completely client side. So
you won't know the first half of my password is pass.
Yeah.
So a question I ask everybody is, do you have a cyber warranty of some kind? Or if not, is there anything about this software do you think is so good or so, built so well that you would be able to warranty it, or you would put a guarantee behind it that it will do exactly what it claims to do?
Good question. Yeah, it's not something we have considered to do, because it's largely visibility into that people haven't seen, but it's not something I considered of it.
But what part of it do you think is like it is bulletproof? Like this works exactly as it claims it's built.
Well, it's super reliable way of detecting identities across anything that's always been logged into, right? Not just across SaaS applications. So the ability to detect identities that are being used on or off a SSO and observe whether they're behind SAML or not is like really, really bulletproof, and that's sent back in a really secure way. So also things like the SSO password protection, like because of the way it works, as I said, it's like you're able to hash the password and see what's actually happened there. It's a really high fidelity way of detecting an attack, right? Because we talk a lot about the pyramid of pain, which is something that detection response teams are really familiar with.
Mm-hmm.
And if if you're familiar with the pyramid of pain, the idea is at the bottom of this pyramid, you have kind of hash values like IP addresses and domains. And when you're at the bottom of the pyramid of pain there, it's like it's really easy to detect stuff like this domain has got a bad reputation of some kind, right? And or match it against something that's known bad. But it's also really easy for an attacker to subvert. So because they can just change the domain and move to something else. So the idea with the pyramid of pain is that you want to be at the top, and at the top of the pyramid of pain is tools and tactics. Because if you're looking at actually their tools and sort of tactics and techniques, attackers have to do those things, right? They're things that you can't get around. You can't really change them. And so we follow that philosophy here with push. So if you look at sort of SSO password protection as an example of that, we're not looking for, oh, this fish kit has got a bad domain or whatever. We're detecting that an employee has just entered their critical password into somewhere that's not the IDP, right? So it's a very high fidelity way of doing something that's at the top of the pyramid paints, tools and tactics, right? So we're not just sort of using these like big magic algorithms. They're like hard techniques that stop these things from happening that we can really stand behind.
Mm-hmm. Out of curiosity, I'm sure some of these sites change their layout or change their login page from time to time. Like, what's the sort of process of detecting that occurred? How do you fix it so that the browsers get the new version? Like, how does that all work?
Yeah, so what's fortunate is we haven't had to build any of our own sort of custom update mechanisms because Chrome and Edge, the ones built by Google and Microsoft directly into the browser, handle all that stuff for you. So there's a pretty rigorous process when you go and get a browser extension up onto this Chrome and Web Store. There's some validations there. You push those out, and then they get distributed out to browsers over time. So we actually just get to follow that process rather than doing anything kind of funky there. So whenever there's some new update, we can push it out, and it propagates out to the normal browsers using that kind of Google's or Microsoft's normal update mechanism for that to happen. So we iterate on those sorts of things pretty quickly. We've got just a huge test rig internally of stuff where we'll detect, and if we see the extension logs into something and it's reports back that there's a URL that used to exist and doesn't anymore, we get on that and we update that. We have a team internally that actually deals and looks at these apps and updates the inventories a lot and does those kinds of things as well. But where possible, and which is actually a lot of cases, we do things fairly generically, like actually detecting a username and password login, you can do kind of generically because, login pages look like a certain way. They sort of do a post with a password field quite often and everything else as well. So yeah, we follow a principle of do it as generically as possible so that we're not really, really dependent on these subtle changes in apps in a high changing environment. And then anything that's very, very specific to that, then our test rig looking at things, detecting and responding to all the time is something we do. So
I could just see some jerk renaming username to uname or something, and just depends on how fragile the logic is there. But if you're abstracting it, maybe that's not as bad as it sounds.
Yeah, because we're sort of looking, remember, for a domain being submitted as opposed to what the username field is called.
Mm-hmm. Yeah. Cool. All right. Well, anything else you want to chat about while we got you here?
Don't think so. No, I appreciate you having me on and
yeah,
giving me the time.
Great. So how do people find you and find Push Security, all that stuff?
So you can visit Push Security at pushsecurity.com. We actually, first 10 users are free, so people can just sign up and try it out. So we find a lot of people will just use the free tier and sort of deploy to 10 VIPs or to 10 admins in the company just to get phishing detection straight away outside of the box. And it can expand out from there. Otherwise, always happy to, if anyone wants to speak to me, adam.bateman at pushsecurity.com, or you can find me on LinkedIn, Adam Bateman.
All right, Adam. Well, this has been great. I really appreciate it. And thanks so much and good luck.
Thanks very much.